Salutations, celestial sightseers. I'm David Fuller. Welcome to Eyes on the Sky. What's up this week? I was at a star party a couple of weeks ago, and on the Saturday that I was there, I happened to be scrolling through Twitter and saw that there had been a supernova discovered the day before. So I thought, I have my camera and my telescope. I'll see if I can get a photo or an image of this supernova. And sure enough, I was able to actually do that. And oddly enough, I had taken a photo of this same galaxy that this supernova popped off in about a month or so earlier. So I had two images to be able to compare it with. Then, about a week later, I took another image of it and I was able to get this. So this is an animated GIF or GIF, depending on how you pronounce it, that shows what that supernova is doing. So my original photo was not all that great. That's this one. It was a little fuzzy. I didn't have great focus, but I was at least able to show that the supernova had where it had, was not before, and then where it was, and then that it had brightened up. So I had April 17th, May 20th, and then May 26th, all in succession. And you can see it brightening. And the thing is, that supernova is still pretty bright. How bright is it? Let's take a look at that. This is the current light curve as of the day that I'm making this video on May 31st. And as you can see, the supernova is still well above magnitude 12. It's it's just under magnitude 11. It's between 11 and 11.5, which is easily visible in most telescopes. Really, something that's probably got a 4-inch aperture or larger should be able to see that even under some reasonably dark skies, and even some light pollution. You might be able to see it if you're able to get away from, block some lights and get some really good dark adaptation. Obviously, the darker skies you're able to get to, the more you would be able to see. But an 11.5 magnitude point of light in the sky is actually fairly bright. And you should be able to see that without too much difficulty, provided you're able to get away from a little bit of some of that light. So where can we find that? This supernova is located in the galaxy of Messier 101. And Messier 101 is located in Ursa Major, perfectly located for most Northern Hemisphere observers right now. If we pull up our constellations charts, we can see that there's Ursa Major. This is sitting at about 10:30 at night from my latitude of around 41 degrees north latitude, and Messier 101 is right here at kind of the end of the handle. The bend star there in the handle is Mizar Alcor. Lots of people have looked at that because it's an easy double star to see even with binoculars, so it's easy to find that, and then you're just going to kind of go this direction to find the galaxy. So I'll show you how to do that. Take those off and we'll zoom in. And you can see there's the galaxy. And really, you just kind of follow a couple stars. There's sort of this, you can almost think of this as like a triangle between Alkaid and Alcor Mizar. Probably easier to go from Alcor Mizar because you can follow Alioth through Mizar and kind of go in this direction. You're going to hit a 4.6 magnitude star. So that's going to be somewhat similar to Alcor, a little bit dimmer by about a half degree. Then you're going to drop down about another magnitude into 5.7 range, and these two stars are 5.7. Once you get here, you actually should have the galaxy pretty much in your field of view if you've got Alcor Mizar at the edge of your field of view. But we'll go ahead and show this centered here. So let's center that and then bring up kind of what a field of view would look like in your finder scope. So that's similar to a finder scope. You're going to have a bunch of stars that are going to be pretty faint. But you should be able to see a 6 magnitude star, and this other one, which is 6 magnitude. You've really got a number of them. So 5.5 here, 4.6, and then this 5.7, which there's these other 5.7 here. So you're going to go 1, 2, 3. And then you're going to follow a line from this star through here towards Messier 101. So this star, which was brighter, 82, is just slightly brighter, by the way, than this particular star over here. And you just follow that line, and it's really about not quite double the distance. But if you get close, even if you are at double the distance, you put that into a wide field of view for a long focal length eyepiece, we can get this. Okay, so this is a 26 millimeter Plössl in a 6-inch f6 reflector. So pretty wide field of view. You've got a field of view about 2 degrees, which is fairly large. But as you can see that even in a 1 degree, you would have no problem having that star and the galaxy in your field of view at the same time. Now, the tricky part is that this galaxy is really, 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 really faint. It is mostly a kind of a washout. So finding the star where you want to see is going to be the real challenge. So as we zoom in a little bit, and when you do use additional magnification, you're going to do 2 things. One, you're going to magnify, obviously, the image of the galaxy itself. But importantly, you're going to darken your sky background. So by doing that, you will actually increase your relative contrast and potentially make it easier to be able to see the galaxy, but definitely where the star is. So let's zoom in one more time after centering the galaxy. We got the galaxy there. Let's up our magnification a little bit. So this is your view at a 1/2 degree field of view, and that's going to be different depending on your telescope and eyepiece combination. But if you do have approximately 1/2 degree field of view, this is what would potentially be in your eyepiece, though much dimmer. Hopefully you would at least be able to see the central region of the galaxy where it's the brightest, although there's not a lot of brightness to this galaxy. It's kind of washed out typically. But if you are able to see that, what you are going to be able to see are a couple things that are going to be similar in brightness to the actual supernova. So you've got this star here, which is almost 12th magnitude, which is going to be similar in brightness to probably what the supernova is. You've also got a star, let me bring this back over this way. You've got a star here that's 11.5 magnitude. That's also going to be similar to what the supernova is. But, so if you have those on either side and you know that the galaxy is in the center, what you want to look for is this arm that does this. Now that's going to be really faint. You probably are not going to see that unless you're looking through a 12, 14, 16-inch telescope under really dark skies. And then you may be able to make that out. But if you keep in mind that that is flipped from what a binocular field of view is. So binoculars, you're coming in and everything is correct left to right, up and down. That arm is on the opposite side from where you're coming in from Mizar Alcor. So see how that arm is over there on this side? And that's where the supernova is. It's way over here. But watch what happens when we do a reflector. See how everything flipped? It flipped left to right and up and down. Now we want to be looking over here. So it may be reversed, and depending on what your orientation is of your telescope and how you're viewing it in the sky, this may be in a different spot. So you have to kind of remember that as you're following it over there. But this bright star-forming region is where the supernova is at. It's just inside here. We'll go back over to my animated GIF image and we'll see that. So see, there's that star-forming region right there, and then there's the supernova right next to it, and here's that arm that kind of has that long tail that's sort of straight off to the side. So there's your supernova, and here's your 12th magnitude stars. There those 2 stars are right here on either side of the galaxy, so they're almost equally spaced across. You're looking for a supernova that is similar in brightness to those 11th, 12th magnitude stars that's near the center of the galaxy. So if you look for that, you just might be able to find it because it's going to be between those and it's over here. So see, there's that triangle. There's where the supernova will be right there. So if you are looking to see the first bright supernova that we've had since, I think, 2011, when the last one exploded and was in this exact same galaxy, Messier 101, take a look. You should be able to see it under moderately dark skies with a moderate aperture telescope, and using the techniques that I just showed you, you should be able to find it. And if you're taking photos, share those with me. I've been sharing some on Twitter, and this is definitely a way that you can do it, and you don't even need a lot of aperture to do it. This is just a 72 millimeter telescope, so you don't need a lot to be able to get this really, really bright supernova SN 2023 IXF, located in the spectacular galaxy of Messier 101. That's all for this week. Keep your eyes on the sky and your outdoor lights aimed down so we can all see what's up, like supernova. I'm David Fuller, wishing you clear and dark skies.